Okay, today we are going to do the lesson on inverse functions, inverse trig functions. This top of this worksheet 3 is totally review. So I'm going to go super duper fast and not make a big deal about it. The tangent looks like this. Whoa, crosses at 0, 0. That was bad. Isn't that lovely? Look at there. See how I did that? And then it would repeat over here somewhere. Cotangent is undefined at the origin, so it's going this way, over here, and over here. And again, it's actually doing those loop-de-loops at different places than something more like that. Okay, doesn't matter, not going to go over domain range. You have all those notes somewhere. Secant. Okay, where are the bumps going up?
At cosine. No, that is cosine.
Plus or minus
It's flips of cosine, so yes, it's here. It's at the origin and da da da. Okay? Yes. And then cosecant is the flip of sine, so it's over here and here and here and here. Okay? Bad pictures, done, going on. All right, before I go on, really quickly, do you remember when you had questions like this and it asked you to find that angle? And you maybe did inverse tangent of 5/12 on your calculator, right?
Yeah.
In degrees. We were only concerned about one answer in degrees because it was a right triangle. We were good.
Yes.
Okay? The actual definition of this function is different than that, okay? We use that button on our calculator, but we're going to talk about what the definition is today. And I need to make this super clear. Super clear. This has infinite solutions. Can you tell me how to write the answer to that?
Oh, pi over 4, I think.
No, it's pi over 6.
Oh. Plus or minus 2 pi.
And then you
And?
get 5 pi over 6 plus or minus 2 pi.
Nice job, Lizzie. Okay. This is asking the same question. Where is the sine 1/2? But it has only one solution. Okay? And now I'm going to talk about why. It has only one solution, which is actually good news, because we hate remembering all that pi over 2 and when you use it and whether it's pi or 2 pi. And okay? So these are going to be easier than you think. This is a sine graph, a very tiny, badly drawn little sine graph. Is it a function?
Yes.
Yeah.
Passes a vertical line test. Is it a one-to-one function?
No.
No. So if we were to just flip this, okay, and do the inverse, we would not get a function. Do you remember when we did some stuff like this? I had this and I said, what would make this have an inverse function that's a function? We'd have to restrict the domain. We said we could cut off that half and then it would be one-to-one. Okay. But we had all the values, we just cut off the negative ones. In order for this to have an inverse function, we need to cut it off. And we want all the values from -1 to 1, so we're going to cut it off here and here and restrict the domain to, does anybody know what those values would be?
Is it pi
Negative pi over 2 to pi over 2?
Yes, negative pi over 2 to pi over 2. Okay? So I need 3 ordered pairs on this sine graph, and then we're going to do the inverse. What are these 3 ordered pairs?
0, 0.
0, 0. Good job.
Pi over 4.
Nope. Pi
No,
over
6.
2, 1.
Oh, yeah.
The other end is negative pi over 2, negative 1. Okay, inverse. What happens when we do the inverse? We still have 0, 0.
Do you have,
But what happens to pi over 2, 1?
it goes to 1 pi over 2.
Right, and I'm going to call this 1 and somewhere up here pi over 2. So over 1, up pi over 2. And this end was negative pi over 2, negative 1. It will become what?
-1 And negative pi over 2.
You can use any scale you want, I'm just, didn't want it to be too tiny. All right, on the, it was kind of doing this shape. Do you remember you have to flip it around the line y equals x to find the inverse? Okay, so the inverse is kind of doing this shape. This is what it looks like. Okay, if you graph it on your calculator, it's going this way. I'm not going to ask you to graph that. I'm just going to ask you to find inverse functions. So Ms. Falzone came up with this awesome idea of coloring a unit circle to remember where we can look for the inverse function. The inverse sign is defined from what did, okay, tell me the domain and range real fast.
It's bracket.
Negative pi
Left
over
to right?
2.
It's negative pi over 2.
Negative
pi.
1, 2, 1.
Negative 1 to 1, left to right, and bottom to top is 2 to pi over 2. Okay, sorry I wrote that really badly. That's supposed to be negative 1. It's wearing a toupee, I guess. Okay. What we're going to do is we're going to take a color, and we're going to write up here the inverse sign is going to be red on mine. And it will fall between negative pi over 2 and pi over 2. Okay? So, on my unit circle, 0 to pi over 2 goes this way up to here. But where's 0 to negative pi over 2?
It's down to 270.
Yes, I'm going this way. Now, I think I was really nice to you, and on your unit circle, I even remembered to cross these out, yes? Because you can't call them 7 pi over 4 or 3 pi over 2 or 11 pi over 6 when you're looking for an inverse function. What do we have to call this according to our range up here?
Negative pi over 6. Negative
Yep.
pi over.
Negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. That's only when we're talking about this as an inverse unit circle. So I'm going to write up here, this is my inverse unit circle. Okay?
It's like the same exact font that you read in this one.
Really? My handwriting is the same?
Yeah, look at that. It's great.
Okay. Now, let me do one quick question. If it said, where is the arc sign, negative square root of 3 over 2, or inverse sign, I haven't used that phrase. Let me go over that in 1 second. But where does this happen? You would say the answer is
Negative pi over 6.
right here, negative pi over 3, right? Because it's sine, not cosine, so it's in the second spot. Everybody okay? You would answer negative pi over 3. Is that easy or what? If you get to use this on a test, you get to pull this guy out and you answer and you're done, okay? Now, I forgot to talk about the notation. Let me go back though to the cosine slides. This means the same as this. So sometimes I will say arc cosine, and the ones on the homework will ask it either way. It's just, I think this is the newer notation and this is the older notation. I could be wrong. They could be still using both of them. This could be, I don't know. But you'll see either one, okay? All right. Arc cosine. This is a badly drawn cosine graph. Where do you think we could restrict this? If we do negative pi over 2 to pi over 2, are we going to get all the answers?
It's not gonna be
No, we'd just have positive answers and it wouldn't even be 1 to 1.
So 0
So then
pi
you
over
have-
2?
Oh,
No, zero.
0. Pi over 2 is way over here and then it wouldn't pass, but what's this halfway? 0 to pi. You guys are geniuses. The rest of the day they can't even figure out what I'm talking about and get in here. It's a 7th period error. All right, so what are the end points And that midpoint, or that, what are the three ordered pairs? That's what I'm trying to say.
0, 1, pi
0,
over 2,
1,
0, and
pi
then
over 2,
pi
0, and pi 1, -1. Okay, so inverse,
It would be pi
1,
over
0.
Oh man, I did this wrong.
Okay,
And then we had
0, pi over 2, and then -1 pi.
Yeah.
Somewhere up there. Okay, and again, this one was doing this shape. If I drew the line through here and reflected it over that, it would be going this way, I'm thinking. So I think it goes down and up like that, but I always look at the one here just to make sure I don't do something stupid. Okay, I totally missed that dot. Okay, pretend that's a shape. Yeah, can you? Okay, there, that green is kind of hard on top of the black. It was 1, 0, 0 pi over 2, and -1 pi. Okay? You're not gonna have to draw these, like I said, you're just gonna have to be able to use the unit circle to find these answers. Okay, the domain is left to right, so we have what?
0 to pi?
-1 to 1,
Ooh.
Okay,
Oh, I
the
did.
range is bottom to top, so we have,
0 to pi.
okay, ready to color?
Yeah.
Okay, the inverse cosine, I gotta find my, here we go. The inverse cosine, you need a different color. Because where are we gonna look for that? We can't look from -pi over 2 to pi over 2, we have to look from
0 to pi.
0 to pi. So what two quadrants do we wanna draw?
1 and 2.
1 and 2. Okay, I don't have to rename anything. I can answer 0, pi over 6, pi over 4, all the way around to pi. Ready?
Oh, beautiful.
All right, arc tangent, one more. This is a tangent graph. Do you remember where the asymptotes were?
One, negative pi,
pi over 2.
No,
Isn't
negative
it
pi
plus
over
or
2.
minus pi
Yeah,
over 2?
yeah.
It is plus or minus pi over 2, because remember the period from -pi over 2 to +pi over 2 is a distance of pi,
Yeah.
and it goes through the origin. Okay, so this is what I'm going to use for my 3 points. X equals -pi over 2, x equals pi over 2, and 0, 0. So what are those asymptotes going to do when we do an inverse?
Are they going to be horizontal?
They don't flip over, they're going to be horizontal asymptotes. Good job, Lily. I don't know what I'm saying. This is going to be y equals, instead, y equals -pi over 2. Y equals +pi over 2. Okay, and then 0, 0 is a point that's on there. Now, if I reflected this, guys, it would go this way. So that's what it's doing, it's going this way.
That's ugly.
Now, be careful. Domain and range, left to right.
Domain is from 0 or infinity to
Negative infinity, then
Range, bottom to top.
bracket of negative. Wait. No, it never goes. So it's yeah. So it's just
But it is
Parentheses.
parentheses. Okay.
let's try this.
So wait, the only point that we like have for certain on there is.
We do. I can give you another one.
But
If
it
you,
would be printed.
if you went over pi over 4, the tangent is 1. Does that sound familiar? Because it's square root of 2 over 2, square root of 2 over 2, so it's 1. So over here is a point pi over 4, 1. So up here is a point 1 pi over 4. If you wanted another one, and down over here would be negative 1, negative pi over 4.
Okay, good.
Okay? Coloring the unit circle. Look at that range. Does it look familiar? Negative pi over 2 to pi over 2?
Yeah, it does. Wait, is it all positive or all negative?
No, it's negative pi over 2 to pi over 2. Right? Here? Okay. So it is the same as the sine. So the tangent is the same. It's not the the answers are not the same. So I'm going to change that. But it is the same coding. It is the same coloring. So if you have a third color and you want to do tangent, you do it in 1 and 4 again. But
It's not brackets. Well,
right, you're right. Okay, it does. It has soft brackets, but look, if you went to this spot at pi over 2 and I asked you the inverse tangent, well, first of all, what would the tangent be up here? Y over x is 1 over 0, which is undefined. So I can't ask you inverse tangent of undefined, because I can't ask you. Okay, I'm not going to ask you. I don't know if I could. I'm not going to ask you. All right. We're done coloring. Are we ready?
No.
Wait, don't keep it there for a little bit.
I like it. It looks pretty.
I feel like this is what some classes do.
Just color all.
Does that mean?
Yeah, those honors kids, they never get to color, huh?
Yeah, we seriously.
You're serious? It's a good.
Except for in honors CWS, we did a little bit too much coloring.
In what?
Ninth grade.
On the honor CWS?
Mhm.
That class is decent. I like
All right, I am going to the back side for the notes. And I have an old unit circle that I've colored here that I've thrown in as a slide. By the way, do we ever look at our inverse unit circle at the third quadrant?
No.
why
No.
not?
So,
Because it's all negative.
well,
Right?
neither of our
Thank you.
inverses were defined that far in that direction. It was either 0 to pi or negative pi over 2 to pi over 2. So we don't ever use that for the inverse. Okay. This question number 1, where is the sign negative 1? That's all it's asking. One answer on your inverse unit circle, where is the sign negative 1? It's negative 1 right down here at the bottom, so we write what? Negative pi over 2. Be careful. You can't call that 3 pi over 2. Okay, arc cosine positive 1. Where's the cosine positive 1?
It's at 0.
Cosine is x, so it is at 0.
Arctangent and
Arctangent, negative
You
1.
don't get, there's undefined. There's nothing, it's not, it's null.
Tangent. How do you find tangent? Tangent is y over x, y over x, y over x. So where is the tangent negative 1?
Pi over 4?
Negative pi over 4, right there. If you put that garbage over that garbage, you'd get negative 1. Okay, where's the cosine positive 1/2?
Negative pi over 3. Wait.
It's positive 1/2.
Okay. No.
Is everybody okay that it's at pi over 3?
Yeah,
I should put negative in front of this. Negative. Negative.
really.
Negative.
Okay, where is the sign positive 1?
Um,
Pause.
is it, yeah, it's pi over 2.
Shadow.
Oh, okay.
Okay, tangent we hate, right?
Yeah,
We gotta really think. Where is the tangent negative? First of all, arctangent negative, where am I looking?
Negative pi. Oh,
is
yeah.
I'm looking down here somewhere, right? And tangent is y over x. So here I would get negative 1 over square root of 3, here to get negative 1, here to get negative square root of 3 over 1.
So it's negative pi over 6.
This one would be square root of 3 over 3 if I rationalized it, right? So it is negative pi over 6.
So, Miss
Yes.
Hafari, I know that you always do like either the top, like just the top two ones, like the, it's weird. Because you do.
Yes, because, okay, let me explain. Negative 1/2 divided by negative square root of 3 over 2 would be negative, I'm doing this one backwards, I'm doing a different problem, I guess.
Over the square root of 3. So that's just cute little.
Okay, yep, we just look at the tops because the bottoms would divide out. Good question. Victor?
So on the inverse unit circle,
Yes?
why did we cross off the bottom left?
There's nothing so many.
Because we can only look for sine and tangent in these two quadrants, by definition, and we can only look for cosine in these two quadrants. We can never have an answer down here in the third quadrant, okay? For an inverse or arc, sine, tangent, or cosine. All right. Where is, this is, you work your way inside out, right? Just like function notation. Where is the cosine negative 1/2?
Negative pi over 3.
And then what is it asking?
Cosine of that.
Yep. What is the cosine at negative pi over 3?
Oh, I don't know. What, not 1/2, no. Who
Negative
knows?
pi over
Negative.
Let's just give up.
Is that right?
Negative pi,
That's not.
cosine, oh, you're in the wrong quadrant.
Yeah, that's what I was saying.
Yeah,
Like,
they
what the
cancel
heck?
each other out. It's like
Cosine
Yes,
of
Shh,
negative-
shh, yes, they do. Yes, they do. But cosine is negative, our cosine, right, is negative only where? We gotta be careful.
Oh, big
It's over
silly.
here.
Oh.
So we're looking at
Yeah.
these values, because cosine is blue. It's negative 1/2 at 2 pi over 3, yes?
Yeah.
Okay, thank you. But then it wants to know, what is the cosine at 2 pi over 3? It is negative 1/2. They just canceled each other out. Now, before you think, whoo, they're all easy when they do that. Let me give you an example where they don't. You're actually right, all 4 of those do, but.
Yeah. Wait, no, that's dumb.
Guys, look, this one does not cancel it out. What is the sine at 5 pi over 4? You go around, it's a regular old sine, go around to 5 pi over 4 and you tell me the sine is?
1/2.
Negative square root of 2 over 2.
Oh, I'm dumb.
The sine of 5 pi over 4.
What are you looking at 5 pi over 4 for, though?
Because it says sine, not arc sine.
It's negative 2.
The regular sine, I'm trying to show you what, yes, Austin, you're right. But the rest of us need to catch up. This is a regular sine, so it can be anywhere, okay? Could be 32 pi over 8, which would reduce, but it can be anywhere. But the sine at that spot is negative square root 2 over 2. Now, the arc sine, I can't go back and say it's 5 pi over 4 because the arc sine isn't defined at 5 pi over 4. Where is the arc sine negative square root over 2 or 2? I got to go down here and answer negative pi over 4. Yes, Austin, you got us there earlier.
But that's not the same one that's on our sheet.
No, I'm telling you, they don't always cancel each other out. Here's an example of where they don't cancel each other out, and you can't just answer 5 pi over 4.
Wait, that wasn't
Okay?
even just an answer. That wasn't even a question.
No, it's not on there. This one says, where is the sine square root of 3 over 2? Just do these with me super fast. Where is the sine square root of 3 over 2?
Pi over 6.
Negative
So-
3. Wait.
What is the sine at pi over 6?
1/2.
I hope not.
Square root of 3 over 2.
I didn't do that.
I don't think that's right.
It's not right. It's 1/2. See, Miss Hobart was right. You thought I wasn't.
No, I knew you were right because they didn't, somebody told me the sine square root of 3 over 2. It's not pi over 6, is it?
It's 1/2.
Guys, no. Where is the sine square root of 3 over 2?
At pi over 3.
At pi over 3.
Dang it.
Okay.
Am I wrong?
No, you're right. You're right. Just don't listen
The
to Eric
sine
because
is
he's
at
listening
square
to
root of
these
3 over
things.
2, okay? So what is the sign at pi over 3 of pi over 3?
Square root of 3 over 2.
Okay. Where is the tangent square root of 3 over 3? Positive square root of 3 over 3. So we're looking for this.
It's pi over 6.
Pi
Yeah,
over
pi over
6.
6.
And what is the tangent when we get to pi over 6?
Negative, well, square root of 3 over 3, yeah.
Yeah, they just undo each other. Okay, this one is the other order. It asks first for the cosine. What is the plain old cosine at pi over 2?
Pi over 2 cosine is 0.
Zero.
Yep.
Okay, and then arc cosine, remember we can only be in quadrants 1 and 2. Where's the cosine 0? At pi over 2, okay? But they don't always cancel each other out, so you have to be careful. All right, I want to get to some other juicy stuff. I am going to skip number 1. I'm going to go really fast because we're running out of time. This is a tangent graph. I'm not skipping, I'm just explaining fast. I'm not going to give you time to think, okay? This is a tangent graph. It goes like this. Does it have an amplitude?
Yes.
No max, no min, so it can't be either of these. What is the normal period for tangent?
Pi.
So pi divided by 1/2 would be
2.
2 pi, so it is choice A. This is an awful question I don't like. If we had a cosine graph, okay, pretend that looks like a cosine graph, and you went to find positive square root of 2, you would go this way how far? Look at your arc cosine unit circle. Square root of 2 over 2, the cosine is? Isn't it pi over 4?
Yeah.
Okay. You would go this way, you would find another one at pi over 4. If it was a plain old cosine, not an arc cosine, I hate this question because you can't do this between negative 180 and 180. But what is pi over 4?
45.
45, and this would be negative 45. Don't worry, you're never going to see that question again, but that's the answer they're looking for. Moving on. Okay, can you figure this one out? Where's the cosine 1/2?
5 over 6.
2 pi over 3.
Cosine is 1/2 at
Pi over 3.
pi over 3, positive 1/2, right? Then it doesn't ask, it says what is the cotangent at that spot?
What?
Well,
Square root
you
of
are
3.
you are at an ordered pair that looks like this, right? At pi over 3. Cotangent is x over y because it's the opposite of tangent. So it's 1 over square root of 3, which is choice
C.
C. Okay, take your time here. Answer carefully. Where is the cosine 1?
0.
0.
Okay, then it says what is the tangent at 0?
No, it's
0.
nothing. Undefined, isn't it?
Nope, the
0.
tangent at 0.
Oh, 0 then.
The ordered pair right here is over 1 and up 0. Y over x, 0 over 1 is 0. Okay, plus, where is the sine 1/2?
Pi over 6.
What is the tangent at pi over 6? The tangent at this point is 1 over square root of 3 or square root of 3 over 3. So what is 0 plus that?
A.
That.
Okay, 0 plus 1 over square root of 3 is 1 over square root of 3, which is this. All right, you do not, oh, yes, okay. Arc sine, I'm going fast. Here's the sine graph. Remember we had to restrict it from here to here. In degrees, that would be negative 90 to 90, right? And it would go from negative 1 to 1. Okay, but if we do the arc sine, we have to flip those. Instead of top to bottom being negative 1 to 1, across is negative 1 to 1, so it's one of these two. Up and down would be negative 90 to 90 in degrees, so it's D. All right, where is the tangent square root of 3 over 3? Positive square root of 3 over 3, or, yeah. Where's the sine positive 1/2?
5 over 6.
What is a pi over 6 plus a pi over 6?
Pi over 3.
2 pi over 6 is pi over 3.
What happened?
So then it wants, what is the cosine at pi over 3? Don't say anything. Zachary, can you look at your unit circle and tell me the cosine at pi over 3? Good job. Always feel like poor Zachary never gets a word in edgewise with you guys.
It's like Hungry Hungry Hippos.
All right, don't talk. Marco, where is the tangent positive 1? Be careful, it's tangent, so you got to do the whole y over x thing.
Pi over 4.
Yep. And what is the sine at pi over 4, Shayla? Square root of 2 over 2, so it's b. All right. You do not have this. I have 90 seconds. Don't leave. You do not have this, but it's on the next test or quiz, I think, as extra credit. You can do these not on the unit circle. The arc cosine is positive in quadrant 1. So if I have a quadrant 1 angle whose cosine is adjacent over hypotenuse, you with me? Can we find this? Can you then tell me the sine of that same spot?
3/5.
Opposite over hypotenuse. Okay, you don't have these on your paper. If you had a tangent that was positive, it would have to be in quadrant 1, arc tangent. Tangent is opposite over adjacent. If I do this, I get square root of 9 and 4 is 13. How'd I do? Okay. Cosecant. Well, it's a flip of sine. Sine is opposite over hypotenuse, so this would be hypotenuse over opposite. All right? Now, in pre-calc, you have to do in calc, I'm going to skip those. Those are easy. We'll come back to them. I'm going to do this F right here. In calc, I keep saying that wrong, you have to do these with goofy letters and pictures. If I do this as over 1, arc cosine. Cosine is adjacent over hypotenuse. Did I miss anybody there? Cosine is adjacent over hypotenuse. I need to write an expression on that leg. Well, right here.
Wouldn't it be 1 squared minus 2?
1 squared minus 2x squared and then square root, right? I can do it leg squared plus 2x squared equals 1 squared, then I'd subtract. Is everybody with me? Now, can you simplify that? Tiny bit. 1 squared is 1, but you can't square root it.
4x squared.
This is 2x times 2x, so it's 4x squared. Okay. Now it wants the sine of this triangle. What is the sine? Opposite over hypotenuse, so it's,
Just that.
okay? If you are on academic team, you may leave. The rest of us are going to do some more of these. Tomorrow, you will have a homework check, and you need to be working on 8.2 tomorrow, okay? 8.2, you have to do worksheet 4B and a book assignment, and it's easy. Easier than this stuff I'm talking about right now.
That's pretty.
Okay. I'm going to go back and talk about this one. This one is very basic because it says the tangent is x. I'm going to make it x over 1. Tangent is what? Opposite over adjacent. Okay. Humor me and find this side then. What expression could I write there?
X squared plus 1 squared.
X squared plus 1 squared, and then the square root of that. But what's 1 squared?
1.
Okay, doesn't simplify. I have to leave it the square root of 1 plus x squared. Now, I really didn't need to know that because this one says find the cotangent. What's the cotangent?
Adjacent over opposite.
Adjacent over opposite is just 1 over x. It's just the flip, right?
Mm-hmm.
Okay.
Wait, and why did we need to find out?
We didn't because I just want to make sure everybody knows how to find it because some of them it'll ask, Instead of arctangent, or cotangent, it might have said sine or something, and then you would need it. It was just nice, easy numbers to practice with, because some of them are really ugly. All right, guys, this one as well, I'll skip the stuff we don't really need to know. Tangent is opposite over adjacent. It wants cotangent, so we'd have what?
Cotangent would be, over two, yeah, no, wait, oh, yeah.
So does it not matter that it's a arctan, it's still opposite over adjacent?
Right, tangent is still opposite over adjacent. Arctan just means it's gotta be an acute angle for it to be positive. I don't know.
So
They
wait.
just, this is the way they do these in calc. I don't know that much about it. I wish Ms. Falzone were here to tell us when you need to know this.
And is tangent to the negative one, isn't that also what cotangent is?
Nope. You need to know that. 1 over tangent is cotangent.
Right, but isn't that
Okay.
the same thing as tangent to
No.
negative one?
Tangent to the negative 1, the answer here is an angle. Okay? This is saying where is the tangent square root of 2, or like 1? It would be at pi over 4. The answer to this is an angle. This is putting an angle in here, okay? One is a reciprocal and one is an inverse, not the same thing. Let me give you an example in arithmetic, okay? You used an inverse, Michael, you used an inverse to solve this, whoops, right? You undid it, okay? You used a reciprocal to solve this, you flipped it over.
Oh, yeah, yeah.
Inverse and reciprocal aren't the same thing, okay? One is undoing something, like adding or subtracting or taking a function of, and one is
The opposite.
flipping it upside down, yep. Does that help explain it a little bit?
Yes.
Okay, let's try this B. Actually, I want time for homework, so can I skip that one? You guys can try that one. Everybody should skip these two, because they're really gross and ugly. I don't know what they are. D and G, maybe? Does that sound right?
C.
C and G? There we are. C and G, skip those two. Let's do one of these, though. And then we're gonna answer homework questions, okay? If we had, this is supposed to be a fraction bar right in there. Okay? If we had some triangle with a arctangent of x and square root of 3, we would put those where? X over square root of 3,
X is across, opposite, and square root of 3 is adjacent.
okay? What could we write on this? Be careful.
Square root of plus
Leg
square.
squared plus leg squared equals hypotenuse squared. So we need to square root it, but what is the square root of 3 squared? Just 3. So it's 3 plus x squared, all under the radical. So cosecant is what?
1 over sine.
Okay,
So.
instead of opposite over hypotenuse, it is hypotenuse over opposite.
Wait, Ms. Hoppower?
Yes.
Since they don't, I mean, you've already told us that, square root shouldn't go in the denominator, so would they like factor that out one time? Like,
If it
how
was,
the
if
square
it's
root-
messy like this, I don't know what they do, because they use these for trading things in calculus. If you wound up with something like that, would they have to worry about that in calculus? Because you use it,
Definitely not.
because you use
And
it
I-
for
and I
other
also
purposes.
think an AP test, not math contest, yes, but not AP test.
Okay? Yeah, these are not on our testing quiz for pre-calc. I'm just trying to introduce you to a concept you're gonna see
And
there,
cry about later.
okay? And cry about later, yeah. One more, or you want homework questions? We can go to homework questions, I'm fine with that. Do you have some?
Yes.
Okay. 8-1 or 8-3? Which one do you want me to
I
open?
think it's 8-3.
8-3?
Yeah.
Okay.
Because I had questions on like the last 4.
Okay.
We were assigned.
I'm gonna talk about 33 first. Does that sound okay?
Yeah, 33
Okay.
and 34.
Because I feel really bad, we did not do one like this. They're not hard, but I don't think there was one in the notes, okay? What we want to do, it says, use the quadratic formula or factoring. If I pretended this was a 3n squared minus 8n minus 3, would that factor?
Maybe.
3n
It's-
and
I did, it
3.
was 6 and like 1/3. Or
Mm,
not. Maybe I'm wrong.
we need a -9 and a +1 as our inside-outside to get a -8. Does that seem okay? Okay? So we're gonna actually factor this. I'm gonna write it out with the sign. Everybody okay? Now, if I set this one equal to 0, I'm gonna get the sine of x is equal to what?
-1/3.
Okay? If I set this one equal to 0, I'm gonna get the sine of x is 3. Picture your sine graph. Max and min. Does it ever hit 3? No. The relationship between a leg and a hypotenuse, if we think of that definition of sine, can never be greater than 1. So this one doesn't have a solution. This one does. It wants the solutions between 0 and 2 pi. In radians. Okay? We want to know where it hits -1/3. So you literally, what you would have done before today probably was just graph y sub 1 equals sine of x and y sub 2 equals -1/3 and find the two decimals that it hits before it gets to 2 pi. And you literally could set your window 0 to 2 pi and then you would make sure you only saw those two. Okay? Now, I would like to briefly talk about how you can do this using your calculator and the second sign button. If you all would put your calculator in radians and do second sine of -1/3, remember, it's going to find the answer closest to the origin, and within our inverse sine or arc sine definition, it's going to find this little decimal right over here, which is -0.34, if I remember right. Anybody getting that?
Yeah, that's it.
Thanks. I'm only gonna round to 2 because I don't want to spend a half hour on this, but, so we got, go -0.34. That's this distance. Does everybody understand that that distance right there is 0.34?
Yeah.
Okay. Before we could solve by graphing on a calculator, what we had to do was think about the fact that if this is back 0.34, this one is how, what?
Plus.
Yes, this is pi plus 0.34. And anybody know what this one would be then?
2 pi minus.
Yes, this one would have been 2 pi minus 0.34. To find those two solutions without graphing calculator, okay? But it's fine, you can graph it.
And those are the 3 solutions.
It only has 2 because it wants the 2 that fall between 0 and pi over 2. So whatever pi plus 0.34 and 2 pi minus 0.34 are the 2 you would find. Do you want me to graph it on the calculator?
Oh, yeah, because 0.34 is behind it? Okay. So
Yes, yes, pi, it's before, right before 2 pi.
Okay, and then can we do 52 and 56?
Yep, I'm gonna move to 52. Everybody okay?
I never,
Same worksheet?
Yeah,
Yes.
same like thing.
I never realized that
Sine
lowering the
squared.
exposure
Oh,
value on
just
a
kidding.
camera made screens easier to see.
And
So
the
wait,
lighting
Oh, yeah,
probably,
there's so much light
'cause
on
we
the
have,
screen and there's not much light
Um,
around it.
we need to do a trade, because
Yeah.
we could do,
Yeah.
there's a double angle trade we could do here for cosine squared minus sine squared, but I don't think that's what we should do. I think we should do, what could we trade for plain old cosine so that we had only sines in this question? Cosine squared is,
I got 1 plus cosine 2 theta over 2.
how about just, what could we trade with your basic trig identities? Basic Pythagorean identity. Basic Pythagorean identities.
1 minus sine squared.
Oh.
Does that make sense?
Mhm.
Other than the fact that Ms. Filzone said it was right. Cosine squared is just a 1 minus sine squared. And then the rest of the problem says a minus sine squared plus a sine.
So it's 1 minus sine? No, 1 plus sine. No, 1 minus 2 sine squared.
Yeah.
Okay.
I'm going to write it as 1 plus a sine of x minus 2 sine squareds of x. Because then I'm going to pretend for a minute that those are n's. If it said 1 plus n minus 2n squared, could you factor that?
I could.
How would that factor?
It's all backwards.
I know, I don't like them when they're backwards either.
Plus one, no, plus one, plus one. So it'd be -2, and,
And I think it's gotta be a positive 2, doesn't it?
well,
To give us a positive 1 in the middle?
oh, it's that, you did it the weird way.
But you can't just well, you could change all the signs, you'd get the same answers in the end. You're absolutely right. Because it's a 0 on the other side, so we could multiply all the way through by a -1 and we get the same answers. Okay. What does this solve to say? The sign, if we set it equal to 0, it will say the sign of x equals
-1. Oh,
Negative
-1/2.
two.
-1/2. And this one will say the sign of x equals?
+1.
Is it,
Do you need me to go through that, Marco? Are you okay with where I got those? I'm just doing the manipulation in my head. Okay. Now, what do the directions say? I need to know that for this section. Are we still on the 0 to 2 pi? Okay. 0 to 2 pi. But we can answer these exactly. So looking only in our whole unit circle, all the way around, 0 to 2 pi, where's the sign -1/2?
7 pi/6.
And?
11 pi/6.
Okay. And where's the sign +1? So there were 3 answers to that question, and we were able to find them exactly. If you had graphed, you would have found decimals, but that's one we can solve exactly. All right? 56 is an application question. If we put in the distances, we need this formula, okay? Does anybody, is it 2,500 and 300 from the question? Anybody looking at the question?
I'm not looking down.
Okay, let me see. It's here, 300 and 2,500, okay? That's where I got those numbers from the question.
I'm staying.
Okay, if you divide all that out, I think you get .88888. Okay?
Just 8888.
Okay, but this is 2 theta.
So you guys wanna find theta?
So
But his is never reliable. What is it?
it's an application. If you're gonna aim your gun, you shoot. You can only aim between 0 and what, 90?
Yeah.
Right?
Yeah.
0 and 90. So if we graph from 0 to 90, but it's a sine of 2x. Let me think about that. The sine of 2x means it finishes by pi or 180, right?
Which would be right because it's only to 90.
Yep, it would have right there. And we want to know where it hits .8888. So,
So there are 2 solutions?
yes, there are 2
Or
solutions.
well, there could be one.
Because, nope, there's 2. You can aim 2 different spots and you'll land, your bullet will land the same place.
You said you're not going to be here for class.
But I will be here
tomorrow,
before
but
and
you'll
after school.
before and
Yep,
after school. I
yep,
just wanted to make
yep, yep.
Thank you.
Yep, thanks for checking.
Would you be able to put the quad program on my calculator?
I can
Oh
do that.
yeah, we were doing that
Oh.
in what's it
Because
called?
chemistry, we're required, like, we need it on there, and it somehow got deleted from mine.
And I could do 34 bucks. And then what's the question for food?
Did you get 2 answers then?
Yeah,
Okay.
I got, yeah. Did you want us to put them in terms of pi or no?
No, I would do degrees just because it's an
Yeah.
application. If you go out to aim your rifle, are you going to know what pi over 6 looks like or something? But you might get an idea of what 30 degrees looks like.
I have them. And then could you just go back to the slide of number 34, because I just want to do it right now.
Yeah, absolutely.
So,
It does factor. You have to get it equal to 0 first, and then I think it factors.
5x squared plus 9. Ew.
Yep,
She reached
that's
out to
fine.
me.
Yep, it's all good.
And she says, I need to call a tow truck.
Okay.
All right, tomorrow, if someone would bring you to work, if you're still short a car, I'll take you home.
Okay. That's fine. And the other option is, we'll see tonight, which
Yeah.
Gary should have an extra vehicle. He left his truck down there. So Zach might be able to use that, but we'd have to get it. So I should
But
probably go
anyway,
call.
I could take you home tomorrow night.
All right, thanks.
Hello. Assuming that is not mentioned, that's pre-health.
Yes.
Fine.
Let's see.
X is equal to -2. Ow. The next one which is -2. Let's divide that. X.
Yeah, gentlemen, open what you think you need there. Okay, first thing, the goal is to have fun. If we happen to get a question right, that's a bonus. And take it easy, gentlemen. Ladies.
Sounds like a low score.
No. Getting something food.
Just really digging in the closet, trying to get this stuff. What is good with them? There were those kind of sweet cartoons.
I'll be back.
There's these two.
You took the whole bag?
I'm not gonna eat the whole bag. I didn't want to like carry the pretzels everywhere. Oh, your bags and the pretzels. The stick ones are better.
It is practically kidding.
No, that's not enough sticks.
Yeah, I know.
I need more sticks. Thank you.
No divisions that the calculation is going to, so all 13 are competing for it.
I had to have my friends do it before me. I don't know what I'm supposed to do.
So, okay, all right, I printed out recording old things, but just a single copy here with scratch paper, so we can kind of pretend like it's the real deal. I don't actually have a copy of time. And, why are you here? Just go for it. Now, some of the problems, the issue is not being as the other one is. Some of them are
So like,
10-minute process.
so we got, for the, not the party, the math team, it's, so we're doing like a two-person thing? And then, so you don't really know what to expect.
But they have like little schedule things that show you like which rooms you're supposed to be in and like what activity you're doing. And like they hand those out to you when you go from class. Why would you say something like that?
Okay, so there's.
Why are you scowling at me?
I'm like,
The last time I did that to someone, I had them gum that was been on the ground. And that was like 3 hours ago. Okay, Seth, he was trying to get him to eat this piece of gum, and I was like, no, no, eat it, eat it. So I like shoved it in his mouth and he ate it. And then
Seth's like, it was nothing right.
oh yeah, Well, I updated it, yesterday,
Or if I have the vector.
and then it didn't even update until like, and then like, it
That's
didn't
really
update.
the same. This is no calculation.
So,
So this is really this vector in the same direction, but the length of this.
no, it's blurry.
That's the
I got
notation
fur
for
on my
that.
face. Put it down.
2, 3 would actually be
I don't like my phone.
rain
Sure,
and
my phone.
stuff
100%
right
sure my phone
there,
is recorded.
and it's length of just factoring in question. So the length of this guy is for 15. So we want to find, what's the length of this guy? 13, and we want to find someone whose length is 39. So I think we should just multiply these by 3. Yeah, so the answer should be, whatever that is, 36 and
God, Paul, we got one in my
15,
throat.
and I should have kept the answer, but maybe I did.
I did.
36 and 15 is the right answer. Now, have to pay.
What is it?
I mean, if you wrote x equals
Oh,
36 and y, they mark it wrong because they want to list it as an ordered pair. Okay. So, understand what question is the issue there, wasn't that?
You broke a piece off, right?
Okay, new problem.
Did it? Here we go. Alright, here we go. Ready?
We haven't done it.
Oh!
Peter.
It's not cheating. It's taking advantage of things.
Basically, it says that we use square root of this guy. I'll let you get some answer. I'm just gonna see if A plus B.
Got it.
But to make this look simpler, why not? Factor square root guys. Okay, by square root size, I get negative 32.
And I'm about to get the materials. And then she
If
said,
I squared this, I get b squared plus 2
Weird, if I use Mario's.
minus a b squared. Now, the only time two numbers equal each other is when their real parts are the same and their imaginary parts are the same.
This is a really good math book.
not cheating.
Not
Mom
good.
called it math club too, and I was like,
Alright, so
there's
this
a big
piece
club.
of junk
And we were just talking about
has
math club
to
and
equal this.
develop theories.
So what do you know about what a and b was multiplied to each other?
I got hit in the face twice with
Yeah.
a birdie
So
today.
a times b
What's all good?
and
Oh,
the real part here is a squared minus the b squared. So a
I saved my
squared
soccer
b
team
squared
from getting
has got to equal a.
eliminated from the tournament
good job.
by taking a